Hello viewer, welcome to Samuel Academy. My name is Samuel. In this video, I want to take you through a journey in the atmosphere, from the surface of the earth to the top of the atmosphere. Welcome. I'll do that in what we call the layers of the atmosphere. Now, air temperature decreases from the surface of the earth up to about 11 kilometers. Alright? Because the atmosphere is heated from below. So when the earth receives the rays of the sun, the rays of the sun, that insolation hits the surface of the earth, and then the layers just in contact with the earth's surface, they get heated by conduction, and then through convection, the layers of the atmosphere above are heated. So we find that the atmosphere is heated from below. That's why air temperature decreases from the surface of the earth up to about 11 kilometers. Now, the rate of change of temperature with height is called the lapse rate. It's about 6.5 degrees Celsius per kilometer. It is called the environmental lapse rate. So in the troposphere, we have a positive lapse rate, whereby temperature decreases with the height up to around 11 kilometers. Alright? But occasionally, the air temperature may increase with the height, producing temperature inversions. Therefore, the lapse rate fluctuates, varying from day to day and from season to season. Okay? Now, in the troposphere, this is the troposphere, from the surface up to around 11 kilometers, where most of the weather is found. In the troposphere, there is mixing of air due to rising air currents and descending air currents. So there is what we call turbulent mixing in the troposphere, where we have rising air currents and descending air currents, right? Now, the vertical profile of air temperature in the atmosphere up to about 30 kilometers is measured by the radiosonde. So we release a balloon which goes to the higher levels of the atmosphere, and on that balloon we attach a machine called a radiosonde. The radiosonde is the one which measures various environmental parameters up there, like wind, direction, speed of wind, air temperature, and so on. So we are saying that the vertical profile of air temperature in the atmosphere up to about 30 kilometers is measured by the radiosonde. Now, after the tropopause, after the troposphere, we have the tropopause. This tropopause is an isothermal layer because temperature does not change as height increases. The rate of change of temperature with the height is 0 because temperature is constant in the troposphere. It is an isothermal layer. Okay? Now, after the tropopause, we have the stratosphere. In the stratosphere, at about 20 kilometers, air temperature begins to increase with the height, producing temperature inversions. Alright? And we consider the stratosphere as a stratified layer. Okay, it's not like the troposphere where we have pronounced vertical motion. Here, the atmosphere exists as layers, stratified layer. Alright? The stratosphere is a stratified layer since the inversion tends to reduce the amount of vertical motion. Okay, so where we have inversions, temperature increasing with the height, we cannot have vertical motions. They are inhibited. So this becomes a stratified layer, right? And the inversion in the stratosphere is due to the presence of ozone gas, okay, which absorbs ultraviolet rays, and for that reason, it absorbs energy, and some of the energy absorbed is used to heat the atmosphere here. That's where we have temperature rising with the height. And in this area, between 20 and 30 kilometers in the stratosphere, that's where we have the maximum concentration of ozone, the ozone layer. Okay. Now, air temperature in the mesosphere. After the stratosphere, we have the stratopause, and from there we have the mesosphere. So we are saying that air temperature in the mesosphere decreases with the height, since there is little ozone in the air to absorb solar radiation. So in the mesosphere, we don't have much ozone as we have in the stratosphere. So there's little ozone to absorb the lethal ultraviolet rays. So in this case, we find that their temperature now decreases with the height. We have a positive lapse rate, just as we have in the troposphere. Okay. Molecules near the top of the mesosphere lose more energy than they absorb, which results in an energy deficit and cooling. So the molecules here in the mesosphere, okay, they lose more energy than they receive. So there is energy deficit and therefore cooling, all right? Now, the region where atoms and molecules shoot off into space is sometimes called the exosphere, which represents the upper limit of the atmosphere. But before that, we have the thermosphere. Okay, the thermosphere is here, and in this thermosphere, we find that oxygen molecules absorb energetic solar rays, warming the air. So you can see in the thermosphere, temperature is increasing because oxygen molecules absorb energetic solar rays and warm the atmosphere. And then after that, we have said we have the exosphere, where we find that atoms and molecules are able to attain energy and shoot off into space. Okay? They attain what you call in physics escape velocity. They are able to overcome the gravitational pull of the Earth, and therefore they can escape into outer space. Right? So that's more about the layers of the atmosphere. I'm sure that this video has been of use and value to you. So I want to request you to subscribe to Samuel Academy for more videos in maths, physics, and chemistry and weather.